Okay, AP Calc kids, so this is lesson 3. All right, we're going to be doing improper integrals where you have a discontinuity. All right, so what's going to happen is we're going to have, all right, if f has an infinite discontinuity, aka vertical asymptote, at, all right, some value, a or b, some constant value, or some constant c in the interval ab, then the integral from a to b of f of x dx is an improper integral. All right, so let's look at some examples. Okay, first example. So we have the integral from 0 to 1 of 1 over x to the 1/3 dx. Where do we have a discontinuity? That's correct, at 0, because it would make the denominator undefined. So there would be a vertical asymptote. Go ahead and graph this function, okay? Graph this integrand, and you will see that that's the case. So here's how we solve it. We get the limit. We can use any letter we want as b approaches 0 from the right. Okay, let me explain this. The reason it's from the right is because when you go from 1 to 0, you're heading towards 0 from the right, okay? Of the integral from b to 1 of x to the negative 1/3 dx. So that gives us the limit as b approaches 0 from the right of 3/2 x to the 2/3, and then you put your bar. Okay, let's, if we want, we could factor out the 3/2. Why not, right? Limit as b approaches 0 from the right. And then we're going to have this x to the 2/3, which is going to become 1 to the 2/3 minus b to the 2/3. Now you need to think about what's going on here, okay? The 1 is no problem. Think about the b. So you are approaching 0 from the right. If you're approaching 0 from the right, then your b, okay, is approaching 0, and 0 to the 2/3 is 0. So this just goes to 0. This goes to 1. So we end up with 3/2 times 1 minus 0, which is just 3/2. Okay, let's take a look at another example. I think this just looks so pretty. I just love this stuff. Just decorate your notebook in it. All right, so we have the integral from 0 to 1 of 1 over x cubed. Oh, remember, this means converge, by the way, just to remind you. It means that the area converges to a number. That is the area, okay? All right, so anyway, so there's an infinite discontinuity at 0 again, so we get the limit as b approaches 0 from the right, because 1 is to the right of 0, of the integral b to 1, x to the negative 3 dx. Now, as you know, that's the limit as b approaches 0 from the right of x to the negative 2 divided by negative 2. I can factor out this negative 1/2. Now, some kids do not do well by factoring out the negative 1/2 because then they forget it. So you have to know yourself. Okay, if you're careless, just leave it in. So now I'm going to substitute in my upper bound. So I have the limit as b approaches 0 from the right. I get 1 over 1. And then I have minus 1 over b squared. So think about it. You're dividing by a tiny little infinitesimal positive number, okay? B squared is a tiny infinitesimal positive number. What happens when you divide by a tiny positive infinitesimal number? That is correct. It goes to infinity. Okay, therefore it diverges. So this whole thing is just going to equal infinity. Well, it's actually going to be negative. This is minus infinity, so let me just do it out. Negative 1/2 times 1 minus infinity. And negative 1/2 times negative infinity is positive infinity. So that means it diverges. All right, I want you to notice something here. You see this exponent? That exponent is less than 1, right? 1/3 is less than 1. You see this exponent? This exponent is greater than 1. So what's going to happen is when you have something like this, all right, anytime the 1/3 you have this power that's less than 1, it's going to converge. And when it's greater than 1, it's going to diverge. What about if it's equal to 1? Example 3. All right, so let's say we have the integral from 0 to 1 of 1 over x. So that's the limit as b approaches 0 from the right of the integral from b to 1 of 1 over x dx. Well, as we know, that is going to be ln. We don't have to worry about absolute value because we're only dealing with positives. So ln of x from b to 1, limit as b approaches 0 from the right. Now, you're probably wondering, do I have to keep writing this limit? Yes, you must. Okay, have fun doing it. Make it look pretty so it doesn't seem like a task. So I have ln of 1, which you guys know is 0, minus ln of b. Now, think about it. Think about the ln graph. Where does the ln graph go as you're approaching 0 from the right? That's correct. It goes to negative infinity. So we have, all right, the limit. Hold on. I already told you what the limit is. So we have 0 minus negative infinity, which is just infinity, so it diverges. Okay, therefore, when you have the integral from 0 to 1 of 1 over x to the p, we'll just call it p, dx, if p is less than or equal to 1, oh, sorry about that, I said it wrong. If p is less than 1, the integral converges. And if p is greater than or equal to 1, the integral diverges. You need to memorize this. This is extremely important. Must know. I'm trying to make a big deal about it. You'll see why when we do series tests. All right, continuing on. Example 4. We have the integral from 0 to 27 dx over the cube root of 27 minus x. Okay, where's the issue this time? At 27, right? Now, 0 is to the left of 27, therefore we're going to be approaching 27 from the left. So we get the limit as b approaches 27 from the left of the integral 0 to b dx over cube root 27 minus x. Now we do a u sub, right? Techniques of integration are still going to sneak into this topic. So we have du is negative dx, so negative du is negative dx. Okay, so that negative I can factor outside. So I have the limit as b approaches 27 from the left. Now we change our bounds of integration, right? Remember making the little chart? So I had originally, this 0, right? So now the 0 is going to, when you substitute it into here, my bound of 0 is going to be 27 minus 0, which is 27. And then my upper bound is going to be 27 minus b. But remember, I have the negative here. So I can put that negative outside in the front, or I can put it in front of the integral. I'm going to put it outside front. If you're going to lose track of it, put it in front of the integral. If you're going to lose track of it there, figure out where to put it, okay? Anyway, so this is u to the negative 1/3 du. You don't have to go back to the x. So I have the limit, negative times the limit, as b approaches 27 from the left, negative 3 u to the 2/3 over 2, and then we have our bounds of integration, 27 minus b. Okay, my apologies, I just realized that I put 2 negatives in this problem. Let me just erase that. All right, so continuing on, I'm going to factor out the 3/2. It helps me to keep track of my negative. So I have the limit as b approaches 27 from the left. And then I'm going to put in my upper bound. So that's going to be my u is 27 minus b to the 2/3 power. So I can write that like this. 2/3, and then 27 to the 2/3 power is just 9. Now think about what happens as you approach 27 from the left. Well, the left of 27 would be something like 26.999. Okay, so what is going to happen when you subtract that from 27 and then square it and then cube root it? That's going to head towards 0. So I have negative 3/2 times negative 9, which is 27/2. You need a lot of common sense with this topic and some good mental math skills as well. Okay, last one. Just like in the last video, okay? All right. One, two, three, four. This is example 5. Okay, I'm losing track. All right, so we have, I lied actually, there's going to be 2 more examples. This is an extremely important topic. Okay, so where is our discontinuity? Our discontinuity is at 1, right? So here's what's going to happen. We're going to split this up from 0 to 1, and then 1 to 3. Okay, I'm not going to write this part here. I'm just going to say you're supposed to write it. Now, over here, we're approaching 1 from the left. Over here, we're approaching 1 from the right. So we're going to have the limit as we approach 1 from the left. the integral of 0 to b, x minus 1 to the negative 2/3 dx, plus the limit as a approaches 1 from the right, a to 3, x minus 1 to the negative 2/3 dx. Okay, so think about it. If you make u equal to x minus 1, du would equal dx. Now your bounds of integration, okay, are going to change accordingly, right? So you're going to have your limit as b approaches 1 from the left. That upper bound, b, is going to now be b minus 1. I'm using this. I'm substituting in b. So this is going to be b minus 1. My lower bound was 0. Well, 0 minus 1 is negative 1. Okay, and then for the other one, similarly, you change the bounds of integration. So you have a minus 1 to 2. You can pause it and process it slower if you wish. Okay, so now I'm going to integrate. So u to the negative 2/3, I bump that up to 1/3. When I divide by 1/3, I can just multiply by 3. Dividing by 1/3 is multiplying by 3. So I end up with u to the 1/3, negative 1 to b minus 1. Same thing on the other side. I have 3 times the limit as a approaches 1 from the right, u to the 1/3 from a minus 1 to 2. Okay, so that's going to be 3 times the limit as b approaches 1 from the left of b minus 1 to the 1/3 plus 1. Okay, because it's minus negative 1, as you know, plus 3 times the limit as a approaches 1 from the right of the cube root of 2 minus the cube root of a minus 1. Okay, so now analyze what happens. Okay, so as you approach b from the left, this b value would be, say, 0.999, because you're approaching 1 from the left. Well, when you subtract 1 from that, you get a tiny infinitesimal number. A tiny infinitesimal number to the 1/3 is 0. So this goes to 0. So this entire thing is 3. For the second one, you have to analyze what's happening, right? So if you analyze this a, so imagine this is 1.00001, right? So you're going to have a tiny infinitesimal positive number to the 1/3. It will still be 0. So this goes to 0. So we have plus 3 times the cube root of 2. You can just leave your answer like that. Now, remember from earlier on when I had the 0 to 1, remember when my power was less than 1, right? That helps you to realize that this answer makes sense. So this converges to this. For some reason, oh, I had a click apparently. Okay, example 7. So let f of x, now this is how difficult these problems can get, equal ln of x, and let R be the unbounded region in the fourth quadrant between the graph of f and the x-axis. Find the area of R. Okay, so this is similar to the last problem in the last video that you start off, okay, the area would just be the integral from 0 to 1 of 2 ln x dx. Now, guess what's coming back here? Integration by parts. So, remember, when we integrated ln x dx, remember the formula. The integral of u dv was uv minus the integral of v du. So, we're going to let u equal ln x, therefore du is dx over x, and then dv is going to equal 1 dx, integrate, remember? So you get v equals x. Lucky number 7. So what does this give you? We end up getting u times v, so that's x ln x, minus the integral of v du. v du, you have x over x dx, so that cancels, so you just get x ln x minus x. Plus c, of course. We're not going to need the c in the end here because this has bounds of integration. Okay, where is the discontinuity? The infinite discontinuity is as you approach 0 from the right. So we have the limit as b approaches 0 from the right of the integral from b to 1 of 2 ln x dx. Now down here, when I did my scrap work, I did not have a 2, so I'm going to have to put that 2 in. So I have 2 times the limit as b approaches 0 from the right of the integral. Oh, I already got the integral. So of x ln x minus x. So that's 2 times the limit as b approaches 0 from the right. I'm going to have, I have to substitute in the 1. And then I have to substitute in the b. So if I substitute in 1, I get 1 ln 1 minus 1. Well, that's 0, so I just get minus 1. Now I have to subtract off b ln b minus b. Blah, blah, blah. Okay, so you need to analyze what's going on here as you go to 0 from the right. Well, as you go to 0 from the right, okay, this is going to head towards 0, this whole thing. So you just get 2 times negative 1, which is just negative 2. All right, that concludes this video. Thanks, kids.